There is a fruit that breaks every rule of modern nutrition. It contains between 20 and 100 times more vitamin C than apples, and it acts directly on the brain's receptors in the same way pharmaceutical sleeping pills do without nausea, confusion, or dependency. Modern biochemical analysis shows that its natural compounds actively reduce cortisol and trigger deep sleep, a mechanism the pharmaceutical industry has spent decades trying to replicate synthetically. For more than 7,000 years, humans cultivated it continuously, carried it along the ancient Silk Road, and regarded it as one of the sacred fruits of Eastern civilization. It was used as a natural sleep medicine long before insomnia became a global diagnosis. Then we didn't stop growing it because it failed. We stopped growing it because it worked too well. A living organism that cannot be patented, cannot be monopolized, and cannot be sold for $40 a bottle has no place in an $80 billion sleep aid industry. It didn't disappear. It was mislabeled and quietly placed on a grocery shelf. If you value the recovery of forgotten knowledge, like and subscribe to support this channel. And now, let's reopen the case file of the fruit that once helped humanity sleep peacefully for millennia. The true archive does not sit inside a museum. It lies beneath ancient soil in the Qi River basin of northern China. In Neolithic storage pits at the Jujia and Wangzhuang sites, researchers uncovered jujube stones preserved almost intact for more than 6,200 years, dating to around 4,200 BCE. When CT scanning revealed their internal structure, the narrative shifted decisively. These were not wild fruits gathered by chance, but specimens bearing clear domestication traits, elongated forms, pointed ends, the unmistakable imprint of deliberate human selection. This means jujube was once a survival choice, not a snack. Ancient texts then seal the record. The Book of Songs marks its harvest season. The Area catalogs 11 varieties. The Huangdi Neijing ranks it among the 5 most valued fruits. The Shenong Ben Kao Jing calls it a superior medicine, and the Qimen Yaoshu provides detailed cultivation and processing methods. Multiple generations, across centuries, independently arrived at the same conclusion. What did they know that we have forgotten? And if archaeology is the birth certificate, the road that carried jujube across continents is the next chapter. It is no coincidence that a species capable of surviving 7 millennia appears along the greatest trade routes in history. Around 2,000 years ago, when Zhang Qian opened the Silk Road, jujube left China with merchants, moving through Central Asia and Persia before reaching Europe. By 79 CE, Pliny the Elder recorded the Chinese date in Historia Naturalis, noting that an advisor to Emperor Augustus brought it from Syria to Italy as a prized novelty. Centuries-old jujube trees still standing in Iran today act as living milestones, reminders that this was not merely a fruit tree, but part of an ancient survival network. From a single center of domestication, it spread to at least 48 countries. In China alone, cultivation now spans roughly 2 million hectares, producing about 8 million tons annually, supporting some 20 million farmers, with more than 800 documented cultivars. A plant does not travel this far if it is merely tasty. It has to be indispensable. But indispensable in what way? Precisely. That answer exposes an uncomfortable paradox. Modern belief assigns vitamin C to oranges, kiwis, and strawberries. Jujube quietly breaks that scale. 200 to 600 milligrams of vitamin C per 100 grams of fresh fruit, 4 to 10 times more than oranges, and up to around 100 times more than apples. When a fruit carrying these numbers is casually labeled Chinese date, history itself becomes complicit in the joke, and vitamin C is only the beginning. Phenolic compounds in jujube range from 275 to 541 milligrams, levels that can be about 5 times higher than cherries, a fruit already celebrated as an antioxidant superfood. In just 100 grams of dried jujube, vitamin C reaches 192 to 359 milligrams, or 300 to 600% of recommended daily intake, alongside calcium, iron, potassium, and a complex fiber profile. Yet the deeper anomaly lies not in the nutrition table, but in the mechanism. Jujuboside A, saponins, spinosyn, camp, polysaccharides, compounds that do not merely feed the body, but interact with the nervous system, immunity, and stress response. This is the kind of benefit industrial food promises, but rarely delivers intact. If a single tree functions as both nourishment and biological support system, the next question is unavoidable. What internal machinery makes such resilience possible? The answer lies in its genome, where jujube behaves less like a crop and more like a living fortress. Its resilience does not come from luck. It is engineered, slowly and relentlessly, at the genetic level. Modern genomic studies describe the jujube genome as unusually compact and purpose-built, shaped by thousands of years of environmental pressure rather than yield maximization. Certain genes act like command centers under stress, regulators that amplify abscisic acid sensitivity to conserve water, heat shock factors that stabilize proteins under extreme temperatures, and ubiquitin systems that rapidly recycle damaged cellular components. Together, they form a coordinated response that allows the tree to remain functional where other fruit species shut down. This is why jujube tolerates temperatures as low as -33 degrees Celsius and continues producing fruit in extreme heat that suppresses apples, peaches, and cherries. Its small glossy leaves reduce transpiration. Its deep root system accesses water beyond the reach of shallow-rooted crops. Its deciduous dormancy protects it through cold, while its minimal chill requirement lets it fruit where winters are shortening. In climate terms, this combination borders on a biological impossibility, a perennial fruit tree that thrives in cold, heat, drought, poor soil, and salinity, while remaining self-fertile and productive for a century or more. The implication is unsettling. The traits agriculture claims it needs for the future already exist, fully assembled, in a species that predates modern farming itself. And if this tree is so biologically complete, the next question becomes harder to ignore. What happens when such resilience intersects with human physiology? For thousands of years, jujube occupied a category that modern systems struggle to define. It was neither drug nor staple, but something in between, preventive medicine embedded in food. Traditional Chinese medicine described it as calming the spirit, nourishing the blood, and harmonizing digestion, language that once sounded poetic and untestable. Modern research has stripped away the metaphor. Jujuboside A modulates hippocampal activity, reducing neural hyperexcitability associated with insomnia. Saponins and flavonoids influence GABA and serotonin pathways, the same systems targeted by prescription sleep medications. Controlled trials show improvements in sleep quality without the daytime sedation, cognitive fog, or dependency risks associated with synthetic hypnotics. Other compounds support immune regulation, neuroprotection, iron metabolism, and gut motility. This is not pharmacology in isolation. It is systems biology delivered as fruit. And here, the contrast sharpens. Industrial medicine treats symptoms episodically, extracting value through repeat dependence. Jujube operates quietly upstream, reducing the need for intervention at all. In economic terms, that makes it inefficient. In biological terms, it makes it profound, which helps explain why, as pharmaceutical sleep aids became a multi-billion-dollar market, a food capable of influencing the same pathways faded from view. The disappearance was not caused by a single failure, but by a perfect mismatch with modern incentives. Early attempts to introduce jujube into the United States relied on seed-grown trees, producing inconsistent fruit and discouraging adoption. By the time high-quality cultivars arrived through formal agricultural exploration, Western food systems were already consolidated around apples, oranges, and heavily marketed commodities. Jujube carried no cultural symbolism, no branding momentum, and no scalable processing industry. At the same time, a new economy was taking shape around sleep itself. Prescription hypnotics and later branded supplements transformed rest into a recurring purchase. A tree that grows for 100 years, resists pests, requires little water, and reduces reliance on medication does not fit that model. It cannot be patented. It cannot be tightly controlled. It does not create dependency. In a system optimized for throughput and repeat consumption, such a plant becomes invisible by default. And yet, invisibility is not extinction. The knowledge persisted quietly in Asia, in small orchards, in research stations, in marginal landscapes where resilience mattered more than margins. What follows is not a rediscovery driven by nostalgia, but by necessity, because as climate volatility accelerates and chronic stress becomes a global condition, the traits once deemed economically inconvenient begin to look less like flaws and more like instructions. What ultimately positions jujube as a threat is not what it lacks, but what it refuses to provide. It offers no lever of control. It does not require proprietary inputs, annual replanting, chemical dependence, or genetic modification to perform. In fact, its strengths directly negate entire revenue streams. A tree that regulates its own stress undermines irrigation systems designed for fragile crops. A fruit that resists pests naturally displaces chemical protection. A food that influences sleep chemistry weakens the logic of nightly pharmaceutical intervention. This is the quiet arithmetic behind its disappearance. Modern agriculture and medicine are not hostile to solutions. They are aligned to dependencies. Jujube breaks that alignment. It embodies a threefold impossibility for industrial systems. It cannot be patented, it cannot be engineered to fail without intervention, and it cannot be monetized through chronic scarcity. In that sense, its absence is not mysterious at all. It is structural. The paradox is that the very traits making it commercially inconvenient are precisely those demanded by a future defined by water stress, soil depletion, and neurological overload. The plant does not compete with modern solutions. It makes many of them unnecessary. Despite this, jujube never truly vanished. It retreated to places where utility outweighed fashion. In China, millions of smallholders still depend on it across arid provinces, cultivating it as both food security and income. In Iran and Central Asia, old trees persist along historical trade corridors. In the American Southwest, scattered research stations and homesteads quietly maintain collections, some trees older than the institutions that now house them. Australia has begun expanding commercial plantings, not because of nostalgia, but because few fruit trees tolerate heat, drought, and salinity while delivering marketable nutrition. These are not revival movements fueled by ideology. They are pragmatic responses to constraint. Each location converges on the same conclusion reached thousands of years earlier. This species performs when systems strain. The convergence is the point. Independent cultures, climates, and economies continue to select the same organism when conditions deteriorate. That pattern is difficult to dismiss as coincidence. What is emerging now is not a rediscovery, but a reclassification. Jujube is being reframed from an ethnic specialty or medicinal curiosity into what it may have always been: infrastructure, a biological buffer against volatility. Research institutions increasingly describe it as a fruit for the future, not because it is new, but because it aligns with where systems are heading rather than where they have been. high vitamin density, neurological modulation, climate resilience, longevity. These traits intersect precisely at the fault lines of modern crises. The significance is not that one more superfood has been identified, but that an old one challenges the assumption that progress must always mean invention. Sometimes it means retrieval. As interest grows among small growers, researchers, and individuals willing to step outside familiar categories, the story enters its final phase, not a call to reject modern systems, but an invitation to widen them, to recognize that some solutions arrive not as products, but as organisms, and once seen clearly, they cannot be unseen. The final step is not persuasion, but orientation. Once you know what to look for, jujube stops being exotic and starts being obvious. A mature tree stands between 5 and 12 meters, its branches growing in a subtle zigzag pattern, often armed with small thorns when young. The leaves are glossy, oval, and resilient, designed to shed heat rather than capture it. Its flowers appear late, pale and understated, avoiding frost by timing alone. The fruit itself tells the rest of the story. Green and crisp at first, then yellow-green with brown freckles when it reaches peak freshness. Finally, deep red and wrinkled as it concentrates sugars for long storage. Each stage is edible. Each stage serves a different purpose. Using jujube does not require transformation into something unfamiliar. Fresh fruit is eaten like an apple. Dried fruit becomes food security, lasting months without refrigeration. Simmered with ginger or other fruits, it functions as a nightly regulator rather than a sedative. Cultures that never lost jujube did not treat it as medicine taken when something is wrong, but as a baseline food that keeps systems from drifting out of balance in the first place. Growing it follows the same logic. Full sun, well-drained soil, minimal intervention. After establishment, water becomes optional rather than mandatory. It fruits without a partner, survives neglect, and improves with time instead of declining. In temperate and semi-arid zones, it occupies a rare niche, a perennial producer where annuals fail and sensitive trees struggle. This is not a call to abandon modern tools or romanticize the past. It is an invitation to recognize patterns. When a single species repeatedly reappears at moments of stress, across civilizations and climates, it is offering information. Knowledge, not consumption, is the action step. Because once you can identify this tree, understand its cycles, and recognize its role, you are no longer dependent on being told what is essential. You can see it for yourself. It never disappeared. While the world looked away, millions of farmers continued to rely on it. Millions of tons were still harvested each year, and its bioactive compounds kept quietly demonstrating benefits that surpass many modern solutions. What was lost was not the plant itself, but the collective memory of why humans once chose it. Preserving that knowledge is not about returning to the past, but about preparing for what lies ahead. And if you think this story was surprising, the next one waiting on your screen explores a fruit that survives where almost nothing else can, with biological strengths that challenge today's assumptions even further. Like, subscribe, and share your thoughts in the comments. Every like and every share helps preserve this knowledge before it disappears again. Thank you for watching. See you in the next videos.